to lecture 7, iterative innovation. So in this lecture, we're going to kind of wrap things up a little bit in the sense that just review our model that we've been able to create so far. And hopefully with all the examples that we gave, that's been fairly straightforward. However, what we're going to do next is to then say that really one pass isn't sufficient, that what you want to do is remove the uncertainty a little bit at a time. So in other words, after one last pass that we've talked about where market and implementation technology all affect each other, if you do gigantic jumps, you're taking a high risk in each one because you're kind of saying, well, based on my limited knowledge, I'm going to zero down on this one application, and based on that, I'm going to zero down here. And so you're not allowing enough of the interaction between a market, implementation, and technology. Basically, you get to work on each one of these things, reduce the risk slightly, and let them converge slower over time. So in a way, it's like taking smaller risk with each pass. So this lecture is about that process. And then just one more step, and we have the full innovation process. So let's start by looking at the model we've set up so far for this process. Here's our graphical representation we've been talking about, where we've been able to narrow down and come up with an explanation that the outside circle represents the number of things that we're considering in each element of innovation, and that these interact over time to bring us down to an innovation. So that's kind of where we've been so far. Now, the process of reducing uncertainty, we've already mentioned and given you examples graphically. The way we're going to represent that here is by looking at the example, which we've talked about various startup examples so far. Let's take the one that's technology motivated and say we start there and we do the work like we talked about, where and I've drawn this out a few times before I've officially defined it this way, but as we reduce uncertainty, we're going to come back and say, all right, fine, we've worked on research, or we've learned particular properties about some of the technologies, or done development work, whatever it is, and we've been able, therefore, for the current market implementation universe that we've created over here, right? So these are, if you will, in this moment, a little bit static. Of course, the truth is these are all like influencing each other constantly, but just like from an iterative point of view, let's imagine that all right, fine, we have this group of applications that can be affected by our technology idea. There's sort of, moderate ways of seeing how they're done. And, by doing research, what we do is we decrease the number of options over here because of knowledge, learning, and abstraction. And so we say, all right, fine. Now, it doesn't mean that I drill in and know everything about one of these particular dots specifically. It says maybe I look at this one, I look at this one, the most relevant ones that I need to kind of decrease risk. And maybe one of these is actually the key thing, and I can't determine what to do with the other ones until I do this one. That's why I do science or research on this one, right? But it's always in the context of, well, the result is going to allow me to know what to do here. And that knowing, if you will, is represented here by then decreasing the number of options that are present in that area. And of course, once you do that, as we've talked about before, once the number of technologies have been reduced, then that, let's say, changes the market applications. For example, some of these purple dots before may have been necessary in order to perform on certain markets, and so therefore, it shifts to the market, and that reduces the number of markets, market applications, right? And of course, now that we have a reduced set of applications and we have sort of a better definition of the technology and science that's occurring, and each one of those is getting more and more resolved with time, now we can think about, well, maybe some of those things that we were thinking of doing, like partnering with, let's say, manufacturing partner X, well, now that we're not really using the technology in the form that was easiest for them, we'll have to change our ideas about implementation. And so, therefore, they influence and narrow implementation. And so you can see what happens over time is that depending on how drastically you do it, and like in the introduction, you don't want to narrow down to one purple dot, one red dot, and one green dot. A lot of people try to do that. They try to accelerate the technology, move too fast, and of course you converge on things that aren't innovations. They don't make it to the market. What's much more a higher probability is sort of, doing concentric changes, narrowing them a little bit, right? Then coming back later and let's say, narrowing them further because now I've done more research or more market application. Again, it can be different ones that narrow it over time. And so, over time, I take small risks in each one, narrowing it until I converge, or I figure out I can't converge. So, just to summarize, the arguments we've been making about these iterations, that, if you do one gigantic iteration, you're kind of making an informed decision, but a slightly informed, because remember, all we're doing at the first pass is getting enough learning of each of those areas and some transactions, right? We're talking to folks, or maybe we're having the first conversation with a corporation. So it'd be like, jumping out, and based on one conversation on the first pass, as you're narrowing things, you then say, all right, here's what we're going to make, and here's how we're going to do it. So I think you can see that, a much more realistic approach is that you want to reduce risk by throwing out ideas that don't work, and you want to do that in a gradual way, because you could be wrong, right? It could be that looks like it doesn't work, but as you throw out more applications and another application comes in to focus, that actually, you're glad that you kept those options open. So it's a matter of reducing options at a rate and a confidence. Now, each one of these decisions is speculative, right? You'd never have perfect information. Again, if you wait for perfect information, everything changes over time anyway, and your path will be disrupted in many different kinds of ways because new things come in. So the reality is you've got to keep on moving forward. You've got to be doing work to narrow technology, doing research or doing development, whatever stage you're at. But you've got to be constantly looking at the market applications, how they change, and looking at how business models and industry structure in the implementation element are changing as well. The key thing is that the process we're talking about, the good process, is that you're constantly experiencing small little failures. So this is a problem for some people because, this idea that we're supposed to, and we'll talk about the errors later, but this idea that you're supposed to be able to map everything out for the first time, write an excellent research plan or business plan, or again, whatever stage you're at, and then not have to come back and modify, which is completely ridiculous. One time I was talking to some folks that were involved in one of the enterprises I was involved with, and I pointed out that the reason that, let's say, a business plan, when you have a small company halfway through the innovation process or wherever it is, the reason that you are changing your business plan is because you're learning, you've got abstraction, and you start to say, you know what, I have a feeling that those markets aren't quite the way that we thought they were when we began, or the technology looks like it might be better for this instead of that. And for all those reasons, you should never believe that you're going to do this once and it's not going to be an iterative process. It's going to be an iterative process so that you can do small failures that hopefully lead you down a fruitful path to converge on a real innovation in the marketplace. And of course, one of the key things too is time. And there's a tendency to think that time and money are always traded off. In the later stages of the innovation process, when uncertainty has been reduced drastically, that is true. At the beginning of the innovation process, people are always amazed because if I throw 10 times as much money at some innovation 20 years away, it does not make that move faster. And the reason is that at some point time cannot be traded for money, that you need to have the appropriate people spend a lot of time doing slow iterations through basic research part of this fundamental innovation process. and arriving on the right scientific goals that guide you over time. So, you're looking at essentially having more options properly vetted, especially in the fundamental innovation process up front, where the questions are bigger. There's fewer of them, but they're larger, and they take time to think about and time to overcome. So all this kind of process, increases the chance. And so that, is the fundamental point of this lecture, that multiple iterative loops through MIT elements occur as one converges on the true innovation, if we're lucky enough to have one.